Magnetic materials are used in various applications such as electronic devices that we use, electric motors, generators, etc. The spin-tronic technology, which is considered to take over the existing charge-based devices, also works based on the magnetism, where magnetic spins are used to transfer and store information. So we see that magnetic materials are very important. And when we are talking about device applications, one issue with that is whenever the temperature increases, the device performance is compromised. That is because the material properties are affected by temperature. And one way to mitigate this issue is to find a material which has properties which are robust against the temperature. And in terms of magnetic materials, this is equivalent to saying that find a material having high magnetic moment in high Q temperature, such that these parameters are least affected at device operating temperature. So in this work, we are interested in finding a material having high magnetic moment and high Q temperature. Our interest is on the Wessler alloys, which are easy to work on and have very promising properties. Our candidate alloy here is cobalt-2 iron germanium. However, in this work, we want to replace 1/4 of germanium atom by iron atom. And there are two reasons for doing so. First, since germanium is a non-magnetic atom, and if we replace this with a magnetic atom such as iron, we can expect that magnetic moment will increase, and that's what we want here. And the second thing is, cobalt-2 iron germanium itself is not a single phase alloy. In case an alloy is multiple phase, the general idea is to dope with a fourth element. However, that can be detrimental because it increases the probability of chemical disorder. But in this work, since we are not adding a fourth element, we can expect that we will also solve that challenge. So from the bulk sample synthesis and characterization, we see that the cobalt-2 iron 1.25 germanium 0.75 is a single phase. It is cubic, and it has the highest magnetic moment and highest Curie temperature among the Wessler family. And from the thin film fabrication and characterization, we see that the films have excellent quality and the properties match the bulk properties. Moreover, the experimental findings are also supported by theoretical calculations. So we see that these all the way after substituting germanium with iron, we see that we have the highest magnetic moment and Curie temperature, and we also the films have excellent quality. So this means that this always is promising for device application. However, what we want to do is we want to further explore its properties such as dynamical properties, spin polarization, so that it can have promising application in other devices as well. I hope I convince you with the introduction here. If you have any questions, please feel free to reach out to me. I'll be happy to answer your question. Thank you.